We are given the function f of x comma y and asked to find the second order partials. Before we can find the second order partials, we need to find the first order partials. Let's begin by determining the partial of f with respect to x, which means we will differentiate f of x comma y with respect to x, treating y as a constant, which means we will treat cosine y to the ninth as a constant, and since the derivative of 4x to the fifth with respect to x is 20x to the fourth, the partial of f with respect to x is 20x to the fourth times cosine y to the ninth. And now let's find the partial of f with respect to y, differentiating f of x comma y with respect to y, now treating x as a constant. And therefore we treat 4x to the fifth as a constant, and then multiply by the derivative of cosine y to the ninth with respect to y, which is equal to negative sine y to the ninth times 9y to the eighth, or negative 9y to the eighth times sine y to the ninth. Notice how we had to apply the chain rule to differentiate cosine y to the ninth with respect to y. Let's go ahead and rewrite the partial of f with respect to y as negative 36 x to the fifth, y to the eighth, sine y to the ninth. And now we will use the first order partials to find the second order partials. Let's first find the second order partial with respect to x, then with respect to y, which means we will differentiate the partial of f with respect to x with respect to y, now treating x as a constant. So if we differentiate 20x to the fourth cosine y to the ninth with respect to y now, treating x as a constant, we will have 20x to the fourth times the derivative of cosine y to the ninth with respect to y, which is equal to negative sine y to the ninth times 9y to the eighth, or negative 9y to the eighth times sine y to the ninth. Let's go ahead and rewrite this as negative 180 x to the fourth, y to the eighth, sine y to the ninth. Let's also record this above. And now let's find the second order partial with respect to y, which means we will now differentiate the first order partial with respect to y with respect to y again. So we will differentiate negative 36 x to the fifth, y to the eighth, sine y to the ninth with respect to y, treating x as a constant, and therefore we'll have negative 36 x to the fifth times the derivative of y to the eighth sine y to the ninth with respect to y. So we'll have to apply the product rule, where we have the first function of y to the eighth times the derivative of the second function, which is the derivative of sine y to the ninth, which is equal to cosine y to the ninth times 9y to the eighth, or 9y to the eighth times cosine y to the ninth. And then we have plus the second function of sine y to the ninth times the derivative of the first function with respect to y, which is derivative of y to the eighth with respect to y, which is 8y to the seventh. Let's go ahead and distribute the negative 36x to the fifth. Negative 36 times 9 is negative 324, so we have negative 324 x to the fifth, y to the 16th, cosine y to the ninth. And then we have plus negative 36 times 8 is negative 288. So let's write that as minus 288 x to the fifth, y to the seventh, sine y to the ninth. The other option would be to factor this, but I'm going to go ahead and leave it in this form. So let's go ahead and record this above. I hope you found this helpful.